Alright, let's solve problem 16-3. We have a hook attached to a rope which is wound around a cylinder with a 2-foot radius. If it moves with an acceleration of 20 feet per second squared, determine the angular acceleration of the drum and its angular velocity after the drum has completed 10 revolutions. Let's start there. So, first thing we want to do is state that A equals alpha R. Rearranging that, alpha equals A divided by R. So in this case, we have an A of 20 feet per second squared, an R of 2, and so alpha is 10 radians per second squared. Using the equation, because we have a constant acceleration, we can use the equation omega squared equals omega naught squared plus 2 alpha constant theta minus theta naught. Okay, and this is to find our angular velocity. So if it moves from rest, therefore omega naught equals 0. And omega squared equals 10 radians per second. Theta minus theta naught would be how far it travels, which is 10 revolutions. 10 revolutions would be 20 pi radians. And then minus 0 since we started from rest. So omega then is equal to 35.45 radians per second. Now the second part, how many more revolutions would the drum turn after it's completed 10 revolutions, and the hook continues down for another 4 seconds. So now we have time in this problem for the first. So we're going to start out with the equation theta equals theta naught plus omega t plus 1/2 alpha t squared. We are going to start from that, but we want to know how many more revolutions. So we can say that theta naught equals 0. So theta is equal to omega naught. Now the omega naught is the starting omega, which is for the second part is now 35.45. So 35.45 times t plus 1/2 alpha, 10 radians per second squared, times time, which is 4 seconds. Putting that into the calculator, and we get a theta of 221.8 radians. The question is how many more revolutions? So dividing this by 2 pi, and we get theta equals 35.3 revolutions.